Good afternoon, guys. Another big question I've been getting lately is how a compass works on a flat earth. Well, once again, it's really simple. A compass can only work on a flat earth. Now, let me get you familiar with a compass really quick in case you've never used one. Now, this compass is accurate. As you can see, the sun is setting over in the west. So as you can see, it's pointing west. Now here's what I want you to notice. I have a magnet here. Now the compass will always, the north, it will always pull to the magnetic pole, which is the North Pole. But here's what I want to show you. Now you have a pull side to a magnet, and you have a push side to a magnet. So we're going to say this is the North Pole right here. Now check this out, what happens to this compass when I do this. It automatically pulls to it. It will always, the north will always go to the magnetic pull. Let's see, you can see this here. Okay, now check this out. Now this side is going to be your push side. So watch what happens when I put the push side to the north. Oops. It automatically pushes the north away. As you can see. Okay, now let me show you how this works on a flat earth. So as you can see here, this is the North Pole. Now that little black dot in the middle, the reason that's black is because in ancient cosmology, this is supposed to be a black magnetic rock in the center of the earth. That magnetic field. All this in here is a magnetic field. Everything will always pull to here and be pushed from the ice wall. Okay, now let's put our compass here. Here's the United States. This is about where I am right here, right now in Illinois. Right here. So let's put that there. We're lined up perfect outside. So of course here's California, so it's going to be to the west. Now, no matter where you are on the flat earth map, going this way will always be the south, and going this way from either of these countries will always be to the north. Now, let me prove something to you. Okay, now let's put the magnetic field in the North Pole. And guess where it automatically points to? Okay, now let's move the compass over here to Africa. Okay, now guess what happens when we put the magnetic field in the center of the earth? It automatically points to the north. So it's kind of hard for me to hold this phone at the same time. So let's go over here to Australia. Now, guess where the compass points? To the magnetic field to the north. So if you'll notice, everywhere that I place this compass, even if it's right here, it points to the north. And guess where? No matter where you're at, the ice wall is always south. So the ice wall works as the push. See, check it out right here. North magnetic pole. The ice wall works as just like the opposite side of a magnet. It pushes. So kind of like right here. Okay, see how it pushes? The opposite side of the magnet will always make it go to the south. So that's why no matter where you are on this earth, let's go over here to Russia. Okay, now watch what happens to the compass when I put the magnetic pole in the middle at the North Pole. It automatically points north. And what's south? The ice wall. No matter where you are, the ice wall is always south. So now hopefully this will make sense to you. If the compass always pulls to the north all the way around this flat earth map, so this is going to be, let's put the magnet there, this way here is always going to be the east, and this way is always going to be the west. Now look at those countries really well. Notice You have an east side and a west side to them. So when the airplane pilot is flying around the world this way, well, of course, his compass is always going to point north, because that's where the magnetic pull is. You see, no matter what, it's always going to point south towards the ice wall. So he thinks that he's making a circle around the world, and he is, but not around the ball. Now, here's the funny thing about that. We are allowed to circumnavigate only east to west on a boat or in an airplane. No one has ever circumnavigated from north to south, which, if this were a ball, which would be starting here, going all the way around and coming back to here. You're not allowed to do it. You know why? It's called the Antarctic Treaty, a no-fly zone. And the reason they make it a no-fly zone is because if someone ever tried to circumnavigate from here, they'd run into the ice wall. They'd never make it back over to here, because there is no back over to here. And they don't want you to know that. And you can look it up yourself. That's why no one ever in the history ever has circumnavigated from north to south. So like I said, that's how your compass works. The north magnetic pole will always pull to the north. It's really, really simple, guys. Okay, now what I'm going to show you really quick is how there's already electricity here on the earth. It's electromagnetic. Just like when you see a storm, you know, lightning, that's electricity. The sun and the moon work off of the electromagnetic field. That's how they, remember, like I told you, that you have the magnetic pull, which is in the North Pole, and then you have the magnetic push, which is the outer ice wall ring. Okay, so when you put something in between those two fields and surround it with copper, just like a fan, if you ever take a fan motor apart, that's what you'll see. You'll see the magnetisms inside the fan with the copper coils in there. The copper coils keep the magnetic field going, which as long as there's electricity going to it, the fan will turn all day long and all night. And if you never unplug it or never turn it off, it'll just keep turning forever and ever and ever until the magnetic brushings burn up in it. Now, the Earth is a much larger scale, so of course that's never going to happen. So the sun and moon will always stay in that magnetic field and turn forever and ever and ever.
An AC induction motor has two basic electrical parts, a rotor and a stator. The stator is the stationary electrical component. It is built by putting together iron layers, forming a group of individual electromagnets arranged in such a way that they form a hollow cylinder, with one pole of each magnet facing toward the center of the group. Magnetic poles are built by winding clockwise and anti-clockwise insulated copper wire. The coils are wound in such a way that when current flows in them, one coil is a north pole and its pair is a south pole. When AC power is connected to the coils, a directional flux is created depending of current's direction and winding direction of each coil. See in this animation how the magnet's polarity changes every half cycle of the AC power supply, creating an alternate magnetic field. The rotor is the rotating electrical component. It also consists of a group of electromagnets, arranged around a cylinder, with the poles facing toward the stator poles. The rotor, obviously, is located inside the stator. As the magnetic field of the stator alternates, due to the effect of the AC power supply, the induced magnetic field of the rotor will be attracted and will follow the rotation. It is a natural phenomena which occurs when a conductor, aluminum bars in the case of a rotor, is moved through an existing magnetic field, or when a magnetic field is moved past the conductor. In either case, the relative motion of the two causes an electric current to flow in the conductor. This is referred to as induced current flow.
The sun and moon will always stay in that magnetic field and turn forever and ever and ever due to electromagnetism. All right, now check this out. I have a battery here. You have your positive and your negative, and this is how the Earth works. That's why you have to have the waters above the firmament and the waters here on Earth. Now, salt water carries the electricity. Now, I'm going to prove that to you really quick. Now, as you can see, I have a battery here running into these wires, which is just a positive and a negative charge, which is causing the light to light up. Now, check this out. I'm going to undo the hot wire, which is the positive. That turns the light off. Now, for right here, look, for example, just check this out. We have a glass of water, okay? Now we have salt. Now check this out. Let's turn this regular water into salt water. Okay, let's stir it up a little bit. Now, watch what happens when I take these two wires get a hold of them here. Watch what happens when I take these two wires, even though I'm not going to touch them together at all. Let's get our light over here where you can see it. Now watch, there's the light bulb. Now watch what happens when I stick the two ends of the wire into the salt water. Boom. See, those wires are not touching. Salt water carries the electricity. As you can see that right there, it lights it up. And that's how your stars work. But here's how your stars work. They have to have the electricity of the salt waters above the firmament to light up. As you can see, the salt water carries the electricity. Really simple, guys. Really simple. Thanks for watching once again.